That's how you submit the assignment, yeah. Once you use the G command, whatever grade you get, that's what's recorded right now.
Okay.
And if the last one that you graded was 10 out of 10, that's a 10 out of 10 for that assignment. All right, so I want to talk a little more about the service learning project, because we were starting to go over that when we ran out of time yesterday. So let's dig into that a bit. So the critical punchline is that your draft proposal of the SLP is due. This says October 2nd. It's actually October 10th. So let me fix that. October 10th is when you need to turn in your first proposal for your service learning project. And this one, I'll take late submissions for 10 points a day penalty, only because you got to turn this in, because this is part of a sequence of deliverables you're going to have over the next 3 quarters, right? So if I don't accept the first one, then you're kind of stuck. So I will take late ones for this, but it's a huge penalty because the whole thing's worth only 25 points. So after 3 days, you've got a 0. So try to get it in on time. But let's talk about what the deliverable itself looks like. So there's this suggested list of topics for your proposal, and again, this is not what you should turn in, okay? You don't take this and just add some words in there. This is a description of the pieces of your proposal that I'd like to see. So definitely include your name, the class, the SE 224, and the date, okay, as with all things that you turn in. And always get in the habit of using your full name, okay? Anything that you're doing in school, anything you're doing in the workplace, always use your full name, okay? Talking informally with people, talking in class, talking to me, first names, nicknames, those things are fine. But I've had cases where 2 students in class had exactly the same name, they didn't know this, and the same last name or the same first name, and there's ambiguity there, so it's just a good habit. So your full name, class, date, and a name for your project. It doesn't have to be fancy, it can just be a descriptive name, but if you've got some idea in mind, for what you're calling this particular project, you can go ahead and put that down just so you can refer to it in your documentation. If you're working with anybody else, make sure you list their names, full names again, okay? And when they turn in their proposal, it should list you as one of their partners and so on. So I want everybody to turn this in, even if you're working in a group of, say, 3 people. I should get 3 copies of this, one from each. And then a project description. Tell me what it is that you want to work on. And this is really the hardest part of the whole thing, I think, is figuring out what you want to do. And there's not a whole lot of boundaries on this, okay? So your first few days of working on this should really be kind of brainstorming, maybe alone or with friends, on what you think might be a cool project to spend 3 quarters working on. And things that people have done in the past, typically video games is a popular one. Trying to figure out how to make an app for a smartphone, Android usually, but sometimes iPhone, to do something. So people have worked on problems that affect them, like I want to make something so that I can know the bus schedule more easily, or something that keeps track of what I have due and reminds me when I should be working on certain assignments. So personal schedulers. But it can be pretty much anything that you're thinking of. And think about what you've done at Clark and what you're going to be doing over the next 3 quarters, right? You're going to be learning a lot of C programming, shell scripting, Unix environment. Well, you can get Unix devices that are this big now, right? Raspberry Pi Zero is gumstick sized. So everything that you're learning in this course, you can apply to a portable device, right? So you can start making smart appliances or things like that. You're going to learn how to make graphical interfaces. You're going to learn Java, which is an object-oriented language. You're going to learn how to make sophisticated user interfaces in that course, which is in spring. You've probably taken or will take 250 and 270, so digital logic and microprocessors. So now you've got more ability to interface to devices, switches, motors, things like that. We've got 3D printers sitting in the collaboratorium that are there for student use. We've got laser cutters. We've got computer-controlled routers, right? you have all these tools and all this knowledge that you've got or are getting. Put that all together and do some daydreaming and think, what would I like to do? What would be really fun? What would I like to come out of Clark and be able to like say, this is what I did when I was at Clark, right? Really, the sky's the limit. The biggest problem is usually picking something that's going to be mostly doable in that time frame, because sometimes our eyes are bigger than the calendar, right? And we want to do everything. But that's a good problem to have. So spend some time next few days sort of thinking about what kind of project would you like to do, and then just a basic plain written description of it, right? It doesn't have to be fancy or formal. I'm not grading this for, grammar or sentence structure or things like that, right? I'm looking for content here. So tell me about your project. And then most challenging elements and expected learning outcomes. A big part of the service learning project is it's a learning opportunity. Okay, it's supposed to extend your knowledge beyond your regular classwork, which means it's a project you want to do, but you don't necessarily know how to do it today. And part of what you're going to do is figure out how to do it and then go ahead and do it. So what are the challenges that you anticipate, and what do you expect to learn in trying to meet those challenges? Description of service components. So this is a service learning project, which means it's of benefit to somebody, right? Pretty much anything you come up with is going to be a benefit. If you make a game, that helps students relax and wind down from school, right? If you make an app, it helps with whatever that app is doing. If you make a solar-powered mole repeller, it helps keep moles out of your garden and it doesn't waste batteries. But think about, a bit of a sales pitch if you were marketing this, right? How do you sell this to somebody and say, hey, this is a really cool project? If you've done any work on this already, if this is a project you've already been working on a little bit, you can talk about that. But as we go through the next 3 quarters, right, you'll have past progress and things you've accomplished, so you can put that in there. Same with current status of the project. If it's brand new, you can just say, this is a new project. And then I want some milestones. So what's a milestone?
Something to keep track of progress that you intend to make.
Right, something that keeps track of progress that you intend to make. If you're traveling on a road, right, it's a stone sticking out of the ground that tells you how many miles you've traveled. Same idea. So you want to make this immersive video game that you wear goggles and it's virtual reality and it's a first-person shooter or whatever, okay? That's a great goal, okay? That's what I want to have by the time spring rolls around, June 2019. If that's your only fixed goal, right, you work on this and other things come up and June rolls around and you either succeeded or you haven't succeeded, right? And that's a really sort of harsh realization. So the idea of milestones is set up some intermediate goals along the way. By the end of week 5, fall quarter, I want to have researched different kinds of heads-up displays and have found one that I can afford and that I think I can learn to use. That's a very concrete goal. It's very, very easy to state. And at the end of week 5, you can look at that and say, have I met this goal or not? Right? And if you have, you're on schedule. If you met it after week 2, you're ahead of schedule. And maybe you should put some more goals in. If you haven't met it by the end of week 5, you're behind schedule now. But it's only week 5, right? And there's time to course correct, to adjust your schedule, to adjust your expectations, and so on. So having milestones is really important. Every few weeks, you want to be able to look at your plan and say, am I on schedule? Am I ahead or behind schedule? And it will keep you from having any unpleasant surprises at the end of the term or at the end of the 3 quarters. So I would like at least 2 specific milestones for this quarter, one for halfway through and one for the end of the term. But you're welcome to put in more. Does that make sense? And then list at least, 2 end of term milestones. And one for midterm. And then list at least 2 general milestones for future terms, winter and spring. And they're going to be kind of general because until you commit, until you achieve a certain amount of progress in fall, you're not going to necessarily know what you're going to do in the future quarters. But basic ideas, right? What would you like to get to in the future? Major challenges anticipated and plans for addressing them. What do you think is going to be the really big hurdle or hurdles that you're going to encounter in this? And there should be hurdles, right? There should not be something you can just sort of do in your sleep and you're done. Because if you can, you're not going to have that learning component necessarily. So what are the big challenges that you see down the road? And then just kind of like partially to give you some thought about it, but also to let me know, why did you choose this project, right? What are your interests that relate to this project? What are you hoping to learn from it? And how do you think this will benefit your education? So just some things to think about and talk about in your proposal. So does that make sense? All right, so this is due October 10th, and it should be typed up. It should be a written proposal. Like I say, I'm not going to grade for format or style or grammar, but think of it as something that you're taking to a venture capitalist and saying, hey, I want $1 million to do this project. Here's my proposal for the project, right? So try to sort of come to it from that mindset. I don't have $1 million to give you, though, sorry. But that sort of mindset. And again, the biggest challenge with the SLP is really picking the right project for you. And that's mostly what you're after in this fall quarter, is come up with an idea and put down some milestones and start doing some research. And if it looks great and the end of the quarter comes and you're like, yeah, I'm right on track, that's great. But chances are somewhere along the way you'll have to make some readjustments, and that's the purpose of fall, basically. And you're welcome to send me drafts of this, or to just shoot me an email or come by and kick around ideas, and we can do some brainstorming and go from there. So don't just think you have to just turn this in and not talk to me before then. It's a back and forth process. All right, so any questions on that?
What if we kind of have an idea of what we want to do?
Great. Yeah, if you've already got an idea, that's good. And you can either go ahead and forge ahead with the proposal, or if you want to bounce ideas off me and tell me what it is and get some feedback, I'm happy to do that. Or if you want to talk to other people, right? And you can, like I say, I want groups to be 3 people or fewer, but you're welcome to, collaborate, brainstorm in larger groups to come up with ideas or discuss ideas, things like that. It's a pretty open environment. All right, any other questions? Cool. So I apologize, I did not post the 224 video yesterday because I didn't upload it by the time I left, and it's hard to upload from home. But I've uploaded it now, so I'll put together a playlist and put that on Canvas shortly. All right, so what I want to talk about today is algorithms. I want to start looking at this question of how we take a problem and break it down into a sequence of steps. And my goal is to pretty quickly get you working on the board in groups, putting together algorithms for some sample problems. And I'm going old school here, and we're going to talk about flowcharting. And people don't really talk about flowcharting much anymore, and most people don't do flowcharts. Flowcharts date back to the 60s. When we wrote code in Fortran, we had lots of Goto statements, and you had to sort of follow the logic, and flowcharts helped disentangle all of that branching. But I will say that most programmers, when they're faced with writing a program, are doing something analogous to flowcharting in their heads, at least, if not on paper. Usually it's more something like pseudocode, where you're writing out a sequence of steps. But pseudocode starts to look a lot like C or Python or whatever you're actually coding in. And it can make it harder to stick with the idea that you're actually writing an algorithm instead of a program. So we're going to play with flowcharting. And you may have touched on flowcharting in 120. Did anybody do that? Okay. And since we're going over this, I'm going to actually do a really brief overview of the official way that flowcharts should be written. And I'm going to ask you to stick with this. It's just some formatting stuff, but but I think it's going to help with our mindset in doing this. So let me do a really brief overview of flowcharting. So idea of a flowchart is basically we're taking the steps that we want our program to perform and we're writing them down in kind of a visual or graphical layout. Okay? And flowcharts are not the same as code. We don't usually write C statements inside our flowchart. We're writing things in sort of plain written language, saying what we want the computer to do, not necessarily saying how we're going to code that. So a flowchart usually looks something like this. It starts with an oval, and the oval is either labeled start or end. Start is the beginning, and end is for the end of the program. And the understanding is this is when you run a program, this is where all the action starts. And things basically flow from top to bottom unless you have an arrow pointing you somewhere else. So I can put a statement under here. And this might be something like, initialize I to 0, or set the sum equal to, something else. And you can have different statements. And you can usually put multiple statements in one of these blocks. But if I'm doing 5 things that are all kind of the same, I might put them in one block. And then if I'm doing 3 things that are different somehow, I might put them in a different block. Okay? Your goal with a flowchart ultimately is to have this visual description of your algorithm that you can map very easily into code. Okay, so that whatever is inside here, you know how to write some statements to do that. So you wouldn't put something in here like, solve the problem, right? I mean, that's clearly what you want to do, but that doesn't map directly into a bunch of C code, right? So how do you solve the problem? So you're breaking it down. Okay, usually our programs are doing input or output, so we have these trapezoids for input or output. So read a number from the user, print an answer to the screen, whatever. When we have a conditional, we use a diamond. And we list some condition. Is X bigger than 0? Is A equal to B? Some kind of condition. And we have 2 places we can come from here. You can put it on the left or the right, or the bottom, right? You can pick any 2. And we usually label them like yes and no, or true and false maybe. And it could be no and yes, right? Whatever works. And basically, if the condition is true, or if it answers to a yes, we come over here and we start doing these things. And if the answer is no, we come over here and we start doing these things. And we could have another condition over here. Which might branch off into some other stuff. And these things can come together eventually. Right, so here's a spot where we checked some condition, and if the answer was no, we did some statement over here. If the answer was yes, we didn't do anything special, we just went on to this block. But if we said no, we did this special block, and then we went on to this one. And maybe at this point, these 2 come together. And we can also do glorious things like have loops. Like at this point, we go ahead and we come back to this part of our program. And maybe over here, we're done. So let's stop or end. Does that make basic sense? So it's a visual representation of what we want our program to do. And this doesn't really always map to C code, for example, or Java or Python, because this was written in an era where we used Goto statements. So down here, I'm basically saying, let's go back up to here. And you could actually say Goto and have a label up here. But if you write assembly language, you use Gotos all the time, right? Because most assemblies don't have structured statements, so we have branches. But for the sake of working on algorithms, I want to stick with this, and even though we've got these arrows going up there, that's okay. my goal is not to be able to write C programs today, right? And we're probably not going to write any C programs this week except for the ODPs. My goal is to think about breaking problems down into these steps. Okay, so so that's a start end. This is a statement. I'm just rehashing. This is IO, and this is a condition. All right, so so let's try one of these together. So let's write a flowchart for a program that will print the numbers from 1 to 10. And there's an easy way to do this, right? We could just say print 1, print 2, print 3. But that's not what I'm looking for, okay? I'm looking for something one step up from that, which is to use some kind of looping and logic to print out the numbers from 1 to 10 without explicitly saying print the number 1, the number 2, the number 3. So I'm looking for some looping and some variables and things like that.
The for statement?
So yeah, in C we would use a for statement, but I haven't really given you that option in the flowchart here, right? So let's break that down, because if we can break a for statement down into these simpler blocks, it's going to help us with making a for statement. Yeah.
Initialize node.
Okay, so let's go ahead and start. And sorry, initialize what?
The integer.
Okay, so what should we call our integer? Okay,
Count.
so set I equal to 0. All right, you had an idea?
I would initialize an integer that has count equals 0.
Okay.
Be specific about what we want.
Okay, so we could call it count or we could call it I. Which is better to use in a flowchart? Probably whichever you prefer, right? So I have a bit of a mantra that I recite a lot in 224 and somewhat in 222 and then less in 223. But my deep belief is that the right way to code something is the way that makes sense to you. Okay? If you think in terms of I is the way that I use something that I want to iterate from some number up to some other number, use I. If you think in terms of I'm counting, so I want to call my variable count, use count. If you think in terms of starting off I at 0 but adding 1 in the beginning, that's fine. Or if you want to initialize it to 1 and increment it at the end, that's fine. Okay? And it's very possible that everybody will come up with a slightly different flowchart, and that's fine. Okay? I'm not going to impose a style guide on you. Okay? People will do that down the road. But I'm interested in your ability to come up with an algorithm. So you suggested initializing to 1?
Yeah.
Okay, so let's go ahead and do that. Let's initialize I to 1, because that's the first number we want to print out. Okay, so what should we do next?
Check to see if I is less than or equal to 10.
Okay. And what if it is?
If it is, then turn down.
All right, so that's an input-output, so I'll use a trapezoid. And what if it's not less than or equal to 10?
Then we stop it.
Then we stop it, so we can just come down here and say stop. All right, what do we do after we print I?
We add 1.
Increment.
Add 1 increment. So now I is going to be 2, and what's the last thing we got to put in here? Loop back up. far should we loop up? Before the conditional. But what happens if we loop all the way back up to here? It's going to be an infinite loop, because every time we come up here, I is going to get reset to 1. And what happens if we loop back to here?
It's going to print once more and then stop. No, it's going to keep printing art.
Right, come back to here, it's going to print, add 1, add 1, it's going to print forever. Right? Pretty clear when you're looking at this that this is the right place to branch to. Not so clear sometimes when you're looking at C code. Right? Definitely not clear when you're looking at assembly language in Engineering 270.
That would only get up to 9. Oh, equal to, my bad.
Yeah, so that's a good observation, right? Since this is less than or equal to, when it's 10, it'll still go ahead and print it.
Okay.
And what's the value of I when we hit stop? That's 11, right? These are all nuances that are pretty clear to see when you're looking at your program like this. Whereas if you say for I equals, or increment file, skip it to 0, in assembly, right? It's not as obvious. All right, so I would say this is a really good flow chart for that first question. But there's also other equally good flow charts, right? You could increment up here and start at 0. You could change your variable names and so on and so forth. All right, so you got the idea here. We have a lot of people in the classroom, so I'm going to suggest we can probably make 6, maybe 7 groups. And we have 33 people in here. So I'm going to say let's do groups of 5 or 6 people. And find a spot on the whiteboard. There's a bunch of markers up here, and there's some erasers. And I'm going to put up another question, so meet some neighbors, find a group, and let's put some flowcharts on the board.
We'll find out. Yeah, I don't know why. I'm not working there.
Yeah.
I'm working at yeah.
Gets annoying.
Got a group.
So your first question is write a program that adds the numbers from 1 to 10 and prints out that sum. And you got to use a loop for this. You can't just add them together with a bunch of pluses. Oh, there should be a bunch of them.
Oh, okay. Oh, just one actually.
Yeah, it's flowchart. Yep.
Basically, yeah, we should have to very close. I and Y. That way we can iterate over I, check to see if it's must have some.
Just set out condition as not as
You sure?
you can keep class to see the reasons.
Oh, yeah, okay. Yeah, all right, got it.
Well, yeah, that's what we'll do, but we're creating a second variable to just set it. I mean, we should set it equal to 0.
Yeah, set it to equal to 0 to just start it off.
No, right side.
I or the head statement.
All right, hold up.
But yeah, not for that out.
Stop.
Well, no, Okay. Oh.
Down.
And then if it is, you would add I to sum.
Plus I.
Oh, we're gonna do that after. That's gonna be another condition.
S equals S plus I.
You can just say plus equal to, right? Yeah. That's technically.
I equals I plus one.
Well, display.
Then you can print something, right? No, you're not yet.
Yeah, I'll put
I know, you print, okay, I know how to.
Print out S. And then you go.
We're gonna use the flood for that.
Alright.
Well, I guess the. And then.
Yeah.
I was just thinking, if you start, when we start practicing, there'd be no case we don't work.
S plus 1 about equals 0.
Because it's like the flood.
1 and 3. 6. Right? I'm just trying to go on. There wouldn't be 7 there.
No, you're right.
It would be 3, 6, because 1, 2, 3, 4, so 10.
Okay. So you could make that.
We should be getting up to 55. And
21 down, 28,
And then after that goes like B.
36,
how'd you guys' days going so far?
First class? First class?
I get you at 7 and I leave at 5 today.
Wednesdays I have until 6. Wednesdays I have until 6. 6 o'clock. Physics.
Engineering physics?
No, just normal. Yeah. Well, I mean, it's like the 3 course. It's like 94. It's
All right, cool. I think everybody's got this problem down.
Well, I guess not.
Let me point out
I
the
have
flowchart in the back left corner here. because it's very different
Sharp
from the other.
for 94 and another one.
So what's different about this flowchart
Levers, whatever.
compared to what most others
Change
did?
it.
I equals 2.
I equals 2,
I thought Sophie.
and some equals 1. So they seeded it with the first value that they were going to add, setting some equals 1, and they started looping from I equals 2. Anything wrong with that? Absolutely not. That's perfect. All right. So lots of different ways to get to the same place. All right. So these all look really good. So let's see. All right. All right, so your next one, you're going to start inputting numbers from the user. And you're going to keep inputting numbers and adding them to a running sum that starts at 0. And you're going to do this until the user inputs a number that's negative. And when they input a number that's negative, you don't add that to the sum. At that point, you just print out the sum, and then your program is done.
Input numbers.
So you input the numbers 5, 6, 10, -4. You can print out the sum of 5 plus 6 plus 10.
So, man?
And the negative number is a flag saying I'm done inputting numbers. Print out the sum at that
I don't
point.
mind.
We can just slide it over and we'll show it. So,
It doesn't really matter.
Next number is oh. Well, I was simply just going to initiate it. That's why I was like the second.
No, yeah.
If you remember, we have the right actual code, so we can just assume that we're
But we need it.
Okay, yes, we
And then we also need this. What do you Conditional. Oh, yeah.
What do we want?
I really have to do it. So I.
I know, I was ready for it. See, but I just was in a circle. I like circles.
If we do smaller, if it is, then
Geometry, I was going to say geography.
yeah, let's do yes first.
Conditional statement, if input is greater
What here? I got it. I'll flip it. There we go. So any positive well, not yet.
We print only this back. Just so we have it. Okay, so now we do the input again.
You guys. You were making reference. Oh, yeah, I'm crazy.
I don't know the exact date yet, so.
Looks really good, except... No, that's okay.
Oh, okay. It's like, maybe we should print the letter S.
So if I is bigger than 0, it's going to add it to the sum. If I is not bigger than 0, it's going to print an exit, right?
I mean, here's a question. Well, is 0 a positive number in your case?
0 is not negative. So it says until the input is less than 0, actually.
So we just get rid of it.
There you go, perfect. Yeah, that looks great.
And erase, I guess?
Cool, that looks great.
Who wants to go next? We might as well come and walk.
All right, everybody's good with this one. All right, so for this next one, if there's one or two people who have kind of been doing most of the talking, I want you to switch it up because we got pretty big groups. And I want to make sure everybody's getting a chance to sort of do the brainstorming part of this. So if one person or two people have been doing most of the heavier lifting, move it around and let somebody else do some of the brainstorming on this. And you can all work together, right? But we want to make sure everybody's getting a shot at this.
You are
That's where I got first.
What are you guys planning on projects?
All right, so same setup. You're going to input numbers from the user until a number is negative, and you're going to keep a running sum. Then I want you to print the average of the numbers at the end instead of the sum. But you get really good at writing.
There's like people that maybe
This
sounds about right, so.
also do 8 with 0 on this one.
or some, you could
Because we need to keep track of how many times we put in a number.
Yeah.